All right. Thank you everyone for joining us today. We're very happy to have you attend this Bird Bite session. A couple of housekeeping things before we get started. First, the session is being recorded, just for your information. And also, please hold all questions you have for our speakers until the end, unless it's a clarifying question, then you're welcome to interrupt. It is my great pleasure today to introduce our two speakers. First, we have Dr. Manisha Desai. Dr. Desai is the Kim and Ping Lee Professor of Medicine, Biomedical Data Science, and by courtesy, Epidemiology and Population Health at Stanford University. She also serves as the Associate Dean of Quantitative and Data Sciences in the Stanford School of Medicine. Dr. Desai is the founding director of the Stanford Quantitative Sciences Unit, which is a collaborative unit comprised of faculty, staff, and trainees who practice data science to address biomedical questions relevant for public health. And some of her recent work involves developing a suite of AI tools to aid the collaborative biostatistician called StatChat. I'd also like to introduce Dr. Leah Welty. Dr. Welty is a professor in the Department of Preventive Medicine, Division of Biostatistics and Informatics, and in the Department of Psychiatry and Behavioral Sciences at Northwestern University Feinberg School of Medicine. She's the director of the Biostatistics Collaboration Center, as well as a co-lead for the Northwestern University Clinical and Translational Sciences Institute. And some of her recent work includes leading the development of StatTag and StatWrap software for supporting documented, reproducible research workflows. So thank you very much, Drs. Desai and Welty, for being here, and I will turn things over to you now.
Hi, everyone. Good morning. Thank you so much, Emily, for inviting us to be here. I'm so glad to be here and to be engaged in this discussion on a topic that is near and dear to my heart, and to be doing it alongside my dear friend and colleague, Leah Welty. So should I kick things off? Okay. Can you guys see my screen okay?
Looks good.
Great. So I'm going to kick us off with a story about reproducibility that I hope will get the discussion going. So I'll start by just showing my team here. Like you all at Kentucky, we have a similar setup. I oversee two different groups, and they're very linked. One is called the Biostatistics Epidemiology and Research Design Group, or the BIRD group, as you all have and are familiar with, and the Quantitative Sciences Unit. So the biostatistics, the BIRD group, is really responsible for a lot of the science behind the translation. We do a lot of sort of matchmaking, and the Quantitative Sciences Unit is where a lot of the long-term collaboration happens. A lot of the translational research questions get addressed. And this is my team here, and I'm telling you this because the story that I'm going to be talking about involves the group, the Quantitative Sciences Unit, where we do a lot of clinical trials, as well as other studies, observational studies, and it really runs the whole gamut. So I like to think of our team as sort of a team science-based collaboratory. We really, really rely on team science principles when we're conducting studies, designing studies, analyzing data. We really like to rely on the whole team. And we really think of ourselves as a collaboratory where we get involved in sort of deep level collaborations. And for most projects, our members are fully integrated into the larger research team, and that is a really key component. And we really like to think of ourselves as conducting reproducible research with rigor. And I'll talk more about that as I talk about this story. So this story took place during the last pandemic that we had during COVID. And, this was a really, really tough situation. And I think a lot of us felt this almost like a call to action, in that, we had this pandemic. We wanted to understand the disease etiology, the epidemiology. We wanted, in particular, to figure out treatments that were going to be helpful. I mean, we're really working at a different pace than usual. We really needed to gain efficiencies in so many different areas of conducting research. And that was very true in our space, and particularly in the clinical trial space. So during that time, we had quite a few people sort of coming to us and saying, can we stand up a clinical trial to evaluate potential treatments? And I'm going to be talking about one particular clinical trial that we conducted during this time. And we were really, while we were conducting this clinical trial and we were enrolling patients, we had our usual sort of protocols in place for how we conduct our trials. We quickly created a statistical analysis plan, we registered the trial, and we were monitoring the data as one would usually do for a clinical trial. And we were eagerly waiting for that last patient's follow-up so we could lock the database and figure out what the answer was, whether or not this treatment was going to be effective. So the whole team was really eager once we had the last patient's follow-up to figure out what the answers were, to start analyzing the data. So when this happened, immediately folks on the team were saying, can you all meaning the biostatistics team, can you lock the database in, say, 24 hours? And we, of course, felt like, maybe we can do this because, we've been monitoring the data carefully, been following our data management plan. So we said, okay, we should be able to do this. The data look good to us. So we're ready to lock. And then the following question was, and can you analyze the data in 48 hours? And that was never done before. We hadn't worked at that speed in the past, and we really thought this was an appropriate question to be asking during this time. And we started thinking about, some workarounds, like maybe we could start with just analyzing the primary endpoint and trying to address the primary objective. And so our team, our sub team sort of did a huddle and said, okay, well, let's get this done in 48 hours. We can do this. So we said, yeah, we're game for this. And what we learned 48 hours later was amazing. We found that we had a positive trial. We don't work on a lot of trials where we get this positive finding, and we thought, oh my goodness, this is really going to change the world right now in this state that we're in. And we thought this was really exciting, and we're eager to bring this back to our clinical collaborators and the larger team. Which we actually did. We actually did do that. So we actually did go and let the larger team know this is really exciting. And we continued to work on our statistical analysis plan and start going through the secondary endpoints. When we found that the secondary endpoints weren't really concordant with the primary findings, that made us start questioning a little bit more. And, as part of our protocol, we always have what we call these reproducibility exercises that we do. And we'd started doing this in clinical trials and then expanded it to observational studies, where we have these reproducibility exercises where we really leveraged the blinded team who's been blinded to go through the SAP and reproduce the analytic file and all of our findings. And so when this happened, I turned to the team and said, we did our usual, right? We did our usual reproducibility exercises. And the team said, yeah, of course we did. And then, I asked the question, well, was there anything that was shared? Because how can we be both, getting the same answer, but it's not concordant with the secondary findings? And then they explained, well, we were pressed for time, so we did share only one thing, which was the definition of the primary outcome. And it turned out that was a really complicated derivation to derive the primary outcome. And so when we dug a little bit more, we found out that there was an error in how the primary endpoint was derived, and that error was shared. And so, the reproducibility exercises, while they were consistent after that point, that was the issue. When we fixed that, we saw that now the primary and secondary analyses were concordant, and there was no need to stop the presses because the findings were negative. Not that the treatment was harmful, but it was not necessarily effective. So we spent a lot of time, trying to figure out what happened, what went wrong. And of course, the obvious answer was that, there was this sharing of the code, and, therefore making this not, we didn't really do our validation. And further, because we were sort of doing this workaround, we were only focusing on addressing the primary objective. Usually we do the whole statistical analysis plan, which really, once we started doing it, started uncovering, maybe there is an issue here, when the secondary analyses did not confirm the primary. So we started thinking about, where did we go wrong? People were very eager to get the findings. We were eager to please. So there was a little bit of a workaround to share the code so that we could get things out quickly. And, really this came down to me not advocating for rigor for the trial during a pandemic. So, one might think, why didn't shouldn't I be advocating for the most efficient way? And of course, but only while retaining rigor. And I really should have known better. And in that sense, I really kind of put my team in a very awkward position. And that sort of, it broke a little bit of the trust that we had within that team. Now, things could have been worse because we did, this didn't get out externally. But it was definitely a challenging time that I wouldn't want others to go through. So a little bit of background into these reproducibility exercises that I mentioned. We have these reproducibility exercises in place as a highly recommended process for our most of our studies, and as a standard operating procedure for our clinical trials. And basically, they are to ensure accuracy. So what I mean, there's sort of two parts to them. One is what we call the statistical validation, where we have the two independent teams implementing the entire plan and making sure that the results are exactly the same. And then we have what we call the clinical validation, where we take these findings to the larger team and make sure that everything makes good clinical sense. So if we're seeing something for viral load, we really should be seeing it for symptomatology. Things like this. Things should be going in the right direction. They should make sense to everyone before we go external. And the idea is that there's so many different ways to interpret the statistical analysis plan. So even when we're writing it and we think we have such clarity, it's only when you go to actually implement it that you see these nuances in how to define outcomes and endpoints. And that's precisely what we found. Was we thought we were so clear about how we were defining that primary outcome that it would be so obvious to derive it. And it turns out that no, there are different interpretations, and there was a different intention that was matched with how we implemented it. So you really learn a lot of this when you go through these reproducibility exercises. You learn all of those nuances. It actually really helps you write a beautiful methods section when you go to write your method section. So our approach has always been to start as upstream as possible in the data generation process and then complete the whole plan. And then I always say this to my team, that we really want to troubleshoot when discrepancies are found. And I should have been suspicious when the team came back and said, oh, everything worked out, we didn't have any issues, because that's so rarely the case. We almost always find, and it really starts with either drawing the consort diagram or that table 1, where we immediately find issues, because most of the issues are found in creating the analytic file, not so much in the beta coefficients that come from a model or something like this. And then usually bringing it back to the clinical team, we'll have additional troubleshooting, and sometimes we'll find issues that are uncovered there. So it's very useful doing this. So the role of the statistical analysis plan is really to aid in rigor and reproducibility in many different ways. And of course, as you all know, this serves as a joint agreement with the whole team. It's a way to get us all on board. And so we really try as much as possible to involve the whole team, even the non-biostatisticians on the team, to agree to the statistical analysis plan. So it's a really great way to get on board with a shared mission. And we try to do this in a way where we're very concise and detailed. So we really have it correspond to one manuscript. A lot of people ask, well, you have a clinical trial, you have so much data. Should you also write out, all the mechanistic analyses and things like this? We really try to get the team to think about what's our manuscript, what's our first primary manuscript going to be, and have a statistical analysis plan that matches that manuscript. Because we understand, especially for a clinical trial, that you're going to have multiple sort of sub-studies or manuscripts. The other thing that we try to emphasize in our plans is that they really must include mock data and mock interpretations. This is kind of our way of almost implementing the plan before we actually see the data. Because as I mentioned, it's when you implement that you really uncover a lot of issues. And that's true with even just drawing up the analysis plan. If you start populating it with fake data and trying to interpret it, you will uncover a lot of issues with the way you defined your endpoint, the way you designed your study. So we try to say that every SAP should have every table and figure that you want for the manuscript with the interpretations. And we think of that SAP to serve as the first draft of the manuscript. And again, the reproducibility exercises involves two teams implementing that plan, comparing findings, troubleshooting, gaining consensus, iterating, working with a larger team that includes the non-biostatisticians, troubleshooting again, iterating. And so the analysis is really this iterative process. So when people ask, when will the analyses be done? You can say, actually, it's going to involve all of us, because it really does involve the whole team, not just the biostatistical part of the team. And I put this up here just to show an example of mock interpretations. And I put this example up here because once we sort of drew out, initially we had just put in our plan, oh, we're going to do a Sankey plot like this. And once we did that, we realized, oh, we really need to think through how we're going to be categorizing our exposure if we want to have a pretty plot like this. And we really need to think a little bit more about our endpoint. It's going to work one way in the analysis, but in a different way if we display it graphically. And so it really gets you thinking further about how you're going to analyze it, whether it's graphical or in your model, once you actually populate it with some fake data, and then you can write out your mock interpretation of what you would like to conclude. And bringing that back to the team while you're in the statistical analysis planning stages is really helpful to get folks to chime in now, rather than coming up with thresholds like this after the fact, after data are seen. So one thing, and maybe this is obvious, but it really became something that I try to stress now to investigators and to the larger team, is that when we ask for more time or for joint timelines and thinking about how much effort to include us on grants and things like this, it's really a matter of rigor and reproducibility. And I think that's a way to really advocate for rigor and reproducibility, is to say, hey, we need enough time, we need enough effort on the grant. And believe me, we all want this. This is going to be good for the team. Really, to put it as something that's really important for the whole team, because really the whole team needs to be working on this. And when it comes to sort of the biostatistical scope and the effort for that scope, that's really something that should be driven by us. I know oftentimes the principal investigator who's may not be a biostatistician may say we think the analysis is going to take this long and this is how much we have, but it's really a discussion that we really need to drive and explain, because not everyone might know about things like these reproducibility exercises. Obviously, with insufficient time, we can make egregious mistakes. So I'll conclude here before turning it over to Leah, and just make a few comments. Often we're asked, how long does it take to code something? And I think it's really important for us to emphasize that the coding is not the rate limiting step when we're analyzing data. It's really all that critical thinking and interpretation and all that iteration that occurs. And that's going to be important for us to articulate that to our investigators when they say, how long is it going to take? Can you start coding now? How long is that going to take? It's not the coding. It's all of the critical thinking that is so important. And, we already know that today with AI, we're going to be getting lots of help in that coding step, but that's not going to replace our critical thinking and the interpretation. So one of the tools we use is the mock data and interpretation to really aid us with the rigor and reproducibility, and we'll be hearing more solutions from Leah in a minute. I also want to emphasize that the reproducibility exercises, and this really hit home for us with this particular example, is that mistakes are often made in creating the analytic file, not so much in the model fitting once you have the analytic file. And these exercises really involve also our non-statistical colleagues to chime in and provide their perspective. Does this make sense? Does this effect size, was that what you were expecting? Things like this. And really, I want to drive that while in this case, this definitely was on me, we really need to shift the burden to the whole team. The whole team must be concerned with rigor and reproducibility. And I will end there and kick it off to you, Leah.
Thanks, Manisha, for a great first half of our talk. I'm going to pick up everyone on a couple of the things Manisha has mentioned. First is really thinking about the team-based aspects of taking responsibility for rigor and reproducibility. And the second is something I think it's really important to acknowledge, that all the things we do are really complex and very sophisticated. So to think that mistakes won't creep in is, I think, unbelievably naive. Instead, what we need to think about is trying to prevent mistakes actively, sort of a dose of preventive medicine, but also thinking about ways to catch them when they happen. And so that's one of the things I love about your story, Manisha, is that's really like, you caught the mistake, which was great before it went out there. There was no paper that had to be retracted. But it did have to also create some soul searching about how to prevent this in the future. So, all right, so to get started here, let me get my mouse in the right spot so my slides advance. Okay, so this is just my disclosure. This has been funded in part by our CTSA. Here's some of my great team members who I've worked with on quite a bit of the work I'm going to talk about today. So like Manisha, I lead sort of a collaborative biostatistics group. This is a picture. It's awfully hard to get everybody in the same room at the same time these days. We're actually 23 faculty and staff. And of course, our mission is to support investigators in the conduct of high quality, innovative health-related research by providing expertise in biostatistics and related areas. And I think it's important to acknowledge that that means we work with a lot of different people. We work with clinicians, we work with social scientists, we work with basic scientists, we work with health services folks. There's a huge range of types of research they do. There's also a huge range of levels of people we work with. We work with very experienced faculty, principal investigators who've been at this for many years, all the way down to postdocs or residents or fellows or even students. So there's just an enormous variety of people we need to collaborate with. And so this is my diagram of how we would like research to happen. So we assemble a team, we have a question, We collect some data, we do some analysis, we get some results, and we disseminate it with presentations and manuscripts. And maybe if we're lucky, that space in the middle takes months or weeks. But I think everyone who conducts research and is part of that process knows it really looks a little more like this, right? Where you have, for instance, people moving on and off your team that are conducting this. You have spaces where you have to go back. Manisha's example is an excellent one where you're doing the analysis and something doesn't quite make sense. And you're like, what happened here? And you have to go back to something analytic or maybe even something in the data collection to say what happened, there's something wrong. So there's this iterative process throughout. And we also do this with just a lot of data, and data is getting messier. So when I think about rigor and reproducibility, what I'm really thinking about is a broader idea of saying what we really need to focus on in our entire research process is reducing variation and managing change in our process from data collection through manuscript preparation and dissemination. So this is a study I conducted because I was just pretty curious to say, well, what do common errors look like? If I'm trying to think about preventing common errors, what are the ones I should think about? I'm always worried, of course, like, oh, are we modeling this correctly? Should we be using an exact approach instead? But, that's maybe not where all the errors creep in. Certainly there are these cases where we've, kind of not got the primary outcome defined as exactly as it should be. Or people make a 0-1 miscode, and it's a very simple error, but it's a very easy one to make. So with some of my colleagues, we conducted a scoping review of 886 articles that were published in fields that we would consider clinical and translational science, and that were retracted. But they were retracted for reasons that were not gross misconduct or ethical issues. It was truly an error that had something to do with the methods or the analysis of the study. This is just kind of an overall summary of what we found. First is that about a quarter of these studies involved Lyme animals, almost 3/4 involved human subjects. And then when we looked at who was collecting data and what was getting retracted, it was really interesting. More than 3/4 were collecting data de novo. 12% had been previously collected for research, and 11% had not been collected for research. So that would be things like an EHR analysis, for instance, or a registry that was not really intended for research, but you could use it for research. And then the type of error. We tried by reading all the articles and reading all their retraction notices to really understand what the errors were. And I will say this was both incredibly time consuming and unfortunately a little bit naive on my part to think that people were actually going to disclose the type of error they had made. Some of the journals were incredibly good. For instance, the JAMA journals have a wonderful policy about how you retract a paper. And for instance, there's the paper that gets published, and then you go through and mark up that paper with like a track changes type version. And then if it's retracted, it shows you basically everything that's wrong. And there's a very good description of why it was retracted. Well, and that's in contrast to other journals to say something like, here's a retraction notice, serious errors were made. Like, I learned nothing from that. So retraction notices, unfortunately, aren't always super forthcoming about what type of errors existed. But we were able to make some broad categorizations for types of errors. And it turns out that about 42% of retractions seem like they were describing errors where it was the process of getting or obtaining the data that was the problem. And just over a quarter cited problems with the analysis of the data. So this was really meaningful for me to say, well, at least among things that are retracted, which means that there's an error and people notice it and actually it gets retracted. So it's a very specific set of things that it seems like we're able to find more errors that have to do with capturing the information rather than our analysis of it. Now, it may just be that errors in analysis are harder to detect, but I thought this was really interesting for me, and it really made me focus a lot on thinking about sort of the upstream process of data collection and data management. Okay. So I want everybody to think about your favorite software that you like to use for analysis and what you put in your methods section when you're describing how you did analysis. this is what we found. And I was really surprised and a little bit alarmed. So when I think of software that I use a lot, I use R, I use SAS, I use Stata. Those to me are like the big ones in the statistical community. And of course, SPSS is very popular too. So Stata didn't even break the top 5 here. Prism is the one in the middle there, GraphPub Prism, that's 11%, very popular in basic sciences. But I was really concerned that 38% of these articles weren't actually telling us what software they used to analyze their data, which we know is an important aspect of reproducibility. So this was kind of looking at it from the field and trying to think about what errors are people making broadly. Something we've also worked on here at Northwestern is thinking about kind of what we call pragmatic reproducibility. We know the research process is complicated and there's a lot of people moving out and you can't always do absolutely everything. And so how can we help people take a pragmatic approach to doing this? So we have a workshop we've put together and we've done it at a couple conferences. And basically the idea here is to not just speak to the biostatisticians, but speaking to people forming their research teams. And just thinking about how all the aspects of your research workflow and your team generation could impact reproducibility. So for instance, like when we're thinking about the team aspect of this, a question is, who am I working with on this project? And then it's really important to say, who are all the people involved, since everything I work on is subject to change in some way, and they may hand off information to each other. So it's really important to understand who they are. And then thinking about how technical are they and me. We don't always have to use technical solutions, but maybe understanding the technical levels of our team. For instance, are we going to be using a bunch of R Markdown, or are people on the team using different tools? So this is something we work on, and we can say, well, okay, in terms of your team, what can change? For instance, maybe we have a postdoc who leaves and we have a new postdoc who starts in the lab. Well, what can we do about that to make sure we stay reproducible and rigorous? And even just something like a getting started document that explains where we store data, where we store code, where we store information about our projects can be really helpful. So we wrote like a perspective type piece on this and thinking about reproducibility in a team environment. And we've kind of got 4 main messages there I want to share. One is that there are lots of software tools out there to help, and I contribute to those. And I think there's lots of really wonderful tools, but it isn't really required. To say that, you're using a particular software doesn't guarantee reproducibility. It can support it. And in the statistics community, I think, early on, reproducibility was synonymous with using something like Sweave or Knitr or R Markdown. That's really changed. There's not really a right or wrong way to approach reproducibility. So there are lots of ways to go about it. So related to my earlier comment, we don't really want anybody to tech shame us in this. There are highly technical solutions and there are some that are less technical. It's really about making sure you're tracking and accounting for change. So kind of to provide an analogy and a more concrete example, I like to think of this as a way to explain the simplicity and complexity of data science. So everybody's familiar with a tap, how it works. You turn it on, water comes out, and you're like, this is great. It works really well. What you don't see is all the stuff happening at a pump station someplace in your neighborhood or city, or maybe it's just a well that's making sure that water flows and comes out. And so when we think about, for instance, research that's using the electronic health record, there's actually a lot of plumbing here that we should probably be aware of. So for instance, we have a data architect who's thinking about how to architect this whole system to collect an unbelievable amount of data. Then we have an ontologist who may be mapping that data to certain standards. Then we have a data engineer or somebody in that type of role who's maybe pulling that information from a health record for us. Then we have a statistician who may be analyzing that data. And then we have a doctor or clinician or a team that's interpreting it all. So there are a lot of complicated handoffs here. And then, of course, this may be happening across a wide variety of software platforms, Java, Python, Jupyter, R. That's just an example. Maybe we're writing the manuscript in Word even. So there's just a whole complicated flow here that we tend to gloss over when we're saying like, oh yeah, I used AHR data to do X. And so when I think about this, there's some questions I want to know, like, is the overall process documented? Are the roles and responsibilities clear? Do people understand kind of where they are in this workflow process and how it relates to others? The data architect may be making decisions, or the ontologist may be making decisions that matter downstream for how we interpret the findings. How much knowledge is assumed along the way? And is it all shared, or is this all in the head of one person? So that's kind of a big ask to think about. One of the ways we've thought about trying to tackle this is through software development. So this is a fairly, this has come a long way, I guess, recently in the past couple of years, called StatWrap. And the idea was to kind of provide a wrapper or packaging around projects to help people keep track of all that information and documentation. That's sort of beyond just what's in the code files or in an SAP. So it's free, open source. It's intended to help cross-disciplinary teams. It's a documentation tool, but I will say it includes both passive and active documentation. It extracts information available in a project, but it also allows people to add their own information. It's intended to be kind of user-centered and technology light. So how this works is it sits on top of, let's say, a set of files you may have about an analysis project. So this is an example project where I've worked on with an investigator for a number of years. And I just connect it basically to an existing file path that has all our work for this particular manuscript. And then I have this dashboard here of things where I have information that StatWrap is gathering for me about the project, as well as things I can add. So we classify those as assets, workflows, people, notes, and a project log. And then there's an embedded markdown editor for the SAP or other information. So I can put it right there so it sits on the dashboard as kind of a reminder, or it can just sit someplace else in a Word file. One of my favorite parts about this is this workflows piece, because it can go into your code files and data and your libraries and create this graphical map of how all the files are connected. So if I'm coming to a project partway through, or if I'm inheriting a project from someone else, this is really, really useful to kind of say, what are like my entry points to understanding the workflow code-wise and how the data is going from one place to another? And what are the libraries or other code files this may rely on? So this is really, really helpful to me. And you can sort it also by, you can list and filter by file type. So maybe I just want to see my R files or something like that. Then there's this notes feature where you can attach notes to files or folders. So, I have an example of a note here. I can say this file with this date is the final frozen data. Now, this isn't, of course, the only place that is documented, but it's helpful to have a note that kind of lives with the file here in this project. And I just have, the earlier poll was for development of preliminary code and analysis. So we can attach things, or you can say something like, this is the entry point for understanding all the code. All right. So finally, there's a project log, which is an overall log of project's actions. And so you can actually search on this to look at keywords, so for instance, if I was looking for something that a person worked on, I could look at that. Or if I could look like final data, I could see that note about which is a frozen data or the final data, things like that. And although I don't have a slide on it here, I don't really have time, we also have developed the functionality for StatWrap to actually generate what we call a reproducibility checklist, where it goes through and it kind of inventories the information it has collected as well as the information people have added to say, here's a checklist that we think is has some things you should pay attention to when you're thinking about the reproducibility of a project. And here's how we can tell from what you've entered here what things are satisfied or not. Okay, so I'm going to switch gears a little bit and talk about something we've also done within our group. This is kind of similar to reproducibility exercises, but a little bit lighter touch, because we also have a number of projects in my center that don't have the resources to have, let's say, double people sort of writing two sets of, both two different people or two different teams executing the analysis plan. Sometimes it's smaller budget. We have one person working on it. We need to make sure they're doing good reproducible work, both for their future self and for anybody else who works on it. So instead, we kind of said, well, we're going to do a code review, and it's going to be a peer-to-peer code review. It was not intended to be evaluative, like the way they work in the software industry. It was much more focused on getting people to think about how you want to document your work so you can show it to someone else, and even show it to yourself, and mentoring, that this is really like a nice peer-to-peer way to share the ways people work on codes. And so we'd have folks each select a project, swap information, and fill out this kind of form that's really like, if you were getting into a project and trying to understand it, these are the things you were looking for. So for instance, file structure, our folders followed our standard organizational structure and where things should live. Like, can I find the data? Can I find a README file? Can I find the SAP? Are file names descriptive and easily understood? Or is there temp 1, 2, 3, 4, 5, 6, something like that? Is there some kind of version control in place that's clear and understandable? So this was interesting too, because it turned out it allowed people to share a lot of tricks that they do in their own workflow that they haven't necessarily thought of as a really nice way to handle a particular coding problem. But it turns out other people are like, wait, that's really cool. I'm going to do that in my code now too. So this turned out to have some really nice sort of cross-pollination. Right, so this reinforces rigor and reproducibility. It's a little bit about self-preservation, a lot about self-preservation. The person who came up with this is our assistant director. And he, whenever we have projects come back where somebody's like left the center or left Northwestern and it comes back to us, he's invariably the one who gets to sort through that and figure out what needs to be done and how we can, sort of update the code and create new analyses. So for him, this was very much a matter of like, I need to be able to do this, and this is one way that'll really help. Okay, so with that, I just want to thank you for the time and opportunity to present this here. I'll just acknowledge my wonderful colleagues, as well as the Retraction Watch database, who provided all the information for our scoping review. There's a couple of publications I mentioned. The references are listed there. And StatRep, as I said, is free and open source. We certainly invite people to check it out and use it if it looks like it'll be useful for you. I've also worked in the past on something called StatTag as well that's got a reproducibility focus there. So with that, I will wrap up. Thank you for your time. And I think we will both invite questions at this point, right, Emily?
Yes, please. If anyone has questions for either presenter, feel free to go off mute and jump in or type in the chat, either way. Also, Lee, I'll say I did not miss your pun about wrapping up your chat about StatRep.
I want to say that our group is going to start doing incorporating the code review, Leah, and that was inspired by your talk.
Okay. So I will give you the fair warning side. I will say my staff did a wonderful job with this. I was just so impressed by them, and how they were willing to share their code and willing to learn from each other. And they were so thoughtful in how they filled out the form. Like, they're like, I thought this was good, but I thought you could do this better. It was just wonderful feedback. I will say it was a little harder to get faculty to do that.
Yeah.
It was just, there was a little more dragging our heels. There was a little more concern about somebody else looking at their code. And it was just really interesting
that's very interesting.
Yeah. So I'm still trying to unpack the psychology of that there, but just so
Yep.
So we're thinking about how version 2.0, I will let you know, but I'll certainly, if you do that, I'd love to hear how it goes for you. I see there's a question in the chat about Stata. Someone asked, I'm actually a big Stata user. I love Stata. I really got used to using it a lot because it has built into it very nicely survey tools for dealing with data that comes from like a large survey that has stratification and weights built into it. And I started working with it long before SAS or R really had the same functionality built in a way that was convenient. So I'm a big fan of Stata. I code with it all the time. I think that, you know, it's trying to get to the same place sort of in terms of its ability to generate dynamic documents that you can with like an R Markdown. But I'm a big user and I'm a big fan. And you can use stat tag with Stata. Also, Stata has a lot of these put doc commands that are very, very helpful and very useful. So I think it's trying to move that direction, but big fan.
What's a put doc command, Leah? Is it?
It's basically Stata's version of like an R Markdown or a knitter type of approach where you can write the Stata file and then it puts all your results in a Word document. And you can put other things too. It's just called put doc. So it's a similar type of tool to generate a dynamic document sort of based on updated results and tables and things like that.
Great. I have one question for you all. Have either of you run into a situation where like time and effort for reproducibility was kind of in conflict with like budget constraints from a funding agency? And how did you navigate that?
Yeah, I'll say that happens quite frequently. Yeah, I can't say I have a really great method of like how do I deal with that? I mean, I try to have these conversations. I'm having one right now with an investigator who says we only have XX amount, and you know, the budget's already gone in. It seems like it could be a really impactful study, and I'm kind of torn because it's an important study. It's impactful. It is a clinical trial. But we simply will not have, I mean, I just know we won't, the space to do reproducibility exercises, to really approach this in a rigorous way. So I'm going to argue, this is just how I'm dealing with this one situation, that, you know, maybe we should be more high level, and we should be the ones that sort of design the study, develop the SAP and all of the analysis planning, and we can be involved in overseeing someone else do this. But because they've kind of split the budget up with like different teams, and they had some of the data management with another team, but it's challenging. I don't think my team would be able to do all of those. So I guess reducing the scope is one solution, and being very clear about what we will take responsibility for. Because another option, I mean, what's also folks are telling me internally is, well, should we be involved if they don't have a mechanism for dealing with this at all? Like maybe we shouldn't be involved. So I'm on the fence about this particular project, and I think this comes up over and over again. Leah, I'd love to hear how you deal with this.
Yeah, I think it's a really hard question, something that comes up on like a case by case basis. I think at one end of the spectrum, you have people that come and they're like, well, we want to do this analysis, but we don't have any money. And I say, I can give you advice for an hour and then good luck. You know, and I can't vouch for that. I can't fix that. I can't do anything with that other than say, please really think carefully about these particular things. I've had an interesting one happen recently. I'll say it was a project I was directly involved in where they'd sort of portioned off the data analysis in two ways. And they said, well, we have the really simple stuff, and we think our team can handle that. We have a research coordinator who we think can handle these basic analyses. We want you and your team to handle some mixed effects modeling. They knew they had repeated measures and they weren't going to be able to account for that with sort of the basic statistical knowledge. So I said, well, okay, this is a little unusual, but okay, at least you're sort of portioning out what you want me to work on, and it's this particular piece. So I did that. And then it became apparent as we were kind of passing tables and documents back and forth that the more basic analyses were wrong. And so that led to a fairly awkward conversation with the PI and the team to say, these are not right. Here is why. And I just presented it as that. I wasn't saying I can't be involved with this anymore, but to say, look, this is wrong. Here's why. And the decision they ultimately made is to say, you know what? We feel like we've kind of we're in over our head. You just take it all over. So I feel like that was a very good outcome. And I said, it's going to be expensive. And they said, that's okay. We can figure that out. So I really want to applaud that team for saying, we're going to make the harder decision, but we want it to be right. And so I think, making sure you're working with people from a place of, we all want to get to a place where it will be right is really important. And advocating for the resources to make it right. I've also had cases where we've gone back to chairs of departments and said, we need some time to finish this in a good way. Your investigator's out of money. Can you help support this to make sure it's right? And most of the time, I think chairs would rather avoid the headache of bad stuff being out there, poor quality, retracted, all of that. And they'll say, sure, if I can throw a little money at this and have it be solid, that's helpful.
Great, thanks. There's a couple questions in the chat that came up. So there's a question about incorporating AI into reproducibility related workflows. Would either of you like to address that?
Yeah, I think this is a really, really important question. And I've been thinking about this a lot, and I think it's inevitable. I know our team is using AI in our workflow. And so, all the lessons I get from Leah, I'm trying to emphasize in our team that we have to think about reproducibility with AI on board if we're using it. And I think that there's going to be parts of our workflow that are might be generative, and that might be important for us to think through. But I think even if AI is being used for coding or to help us with coding, I think we can still use all of the techniques that Leah was talking about, because we need to be able to document and archive our code. So Leah, I'm going to turn it to you. How do you think about it? Because I know you were talking about like different software. It doesn't you're kind of software agnostic, and AI you can think of as sort of like adding that to the mix. How do you think about it?
Um, many thoughts here, I suppose. I think the first part is, um, AI is pretty amazing. And I will say I had a problem the other day where I was working on the analysis plan for something. I was like, I don't actually know what I need to do in this case. I had some correlations and I had some complicated nesting structure, and it was rank values. It wasn't continuous. And so I needed to account for like all this nesting structure, but a Spearman doesn't do that automatically. And so I was like, let's just see what Copilot says. And I put kind of a prompt into Copilot, refined it a little, and it gave me 5 ideas. 3 of them I dismissed as really bad ideas. 2 of them I was like, well, I thought of that one, but I don't really like it for some reasons, but it's plausible. And then the 5th one, I was like, I like that idea. That was very helpful. So I put that one in my analysis plan. Now I'm ultimately taking responsibility for saying we should do X, but it was very helpful to have AI spin out some brainstorming ideas. It was useful. Also for me to know, like, there wasn't a standard off the shelf thing that I was somehow missing buried in the literature someplace was at least some validation, maybe not perfect, but it was there. And of course I use it like everybody else to say like, oh, I need to fix this thing in my code. Can you help me do that stuff? So, I think we should be using AI. I want to make that statement. I think we absolutely should be using AI. It's, incredible what it can generate. It is pretty efficient. Should it replace us? Absolutely not. I can vouch for rigor and reproducibility of what I'm doing and thinking about all those processes around it. AI cannot. AI is like unbelievably irreliable in terms of its reproducibility. You like ask one thing one time and you ask it another thing another time, and it's totally different. In this case, I was using it as an example. I saved my prompt on the output just to make sure I had what it was there, because I knew it could change if I asked again. I will say in terms of like a broader team-based collaborative practice, I have seen a lot more people coming into our center and saying, I think I know what to do for the statistical analysis. Can you just check my approach and see if you think it's right? And I'm pretty sure they've put their prompts in AI and they want me to kind of bless a statistical analysis plan. Well, I appreciate they're coming and getting involved, but then I'm really going to need to get involved and see what I actually think of that plan. And then the second thing we're seeing is people coming with code and they're saying, we've got all this code to do this problem. Do you think it's right? And I'm like, That's going to be an expensive question to answer. Probably easier if you just let me do it and me use the AI as needed to generate this. So I'm actually working on a separate thing I want to do is basically called like should AI replace your biostatistician?
I love that answer, and I will say I wholeheartedly agree. I think, and we're also developing some AI tools. And my belief, I agree with Leah. We should be embracing it and using it to enhance and help us. I think it needs to be maybe not created by, but if we can create it, I think even better. And that's sort of behind the idea behind Stat Chat that we're creating in our group. And evaluated by us, vetted by us before being adopted by us, and exactly like Leah's saying, like not to replace our critical thinking. The critical thinking piece always needs to be there, and I think it's going to be challenging as we go forward to, maybe challenging to sort of adhere to our reproducibility rules, but I think that's going to be really important. So as long as we have and stick to those principles, I think that's going to be really, really key.
Yeah, Manisha, I would love to hear more about Stat Chat sometime.
Yeah, I'd be happy to talk about it at some point.
Great. Well, we are going to have to wrap up. So if we did not get to your question, please feel free to reach out. But at this time, I want to thank Dr. Welty and Dr. Desai so much for sharing your insights. We really, really appreciate it. And I will turn things over to our wonderful program manager, Sarah, who's going to share a little bit about the next Bird Bites.
Thank you, Emily. And again, another just round of thanks to Dr. Leah Welty and Dr. Manisha Desai for joining us today and sharing the wonderful practices that they do at Northwestern and Stanford, respectively. I am sharing my screen now to show our upcoming Bird Bites, also throwing a couple links for you all in the chat. Feel free to reach out to Manisha and Leah at their respective emails and look for an announcement for our next Bird Bites. It's on April 27th from 12 to 1 p.m. Joining us will be Dr. Lindsay Hammerschlag, an associate professor in the Department of Biostatistics, to talk about her projects utilizing dynamic data dashboards for public health informatics. Examples from RADOR, which is the Rapid Actionable Data for Opioid Response in Kentucky, and KYOACC, which is the Kentucky Opioid Abatement Advisory Commission. We would love to see you all there. I also want to put in a plug. If you are not part of the CCTS emails, please jump on that. And also follow the Center for Clinical and Translational Science on LinkedIn, which is a new page. So please follow us, Facebook, Instagram, and X. So thank you again to Leah and Manisha. It is an honor to have you all here and sharing your practices with us. And we hope to see you all at Bird Bites soon. So any further questions, or Emily, are we good? Okay.
That's it. Thank you, everyone. Thanks again, Leah and Manisha. Bye, all.
Thank
Thank
you.
you.
Thanks so much.
Bye, all.